Hello everyone. Next topic is we will discuss hysteresis. What is hysteresis? Hysteresis means the streaking property of ferromagnetic material is the relation between magnetization and the strength of magnetic field. This property is called as hysteresis, or the hysteresis the below critical or Curie temperature. The ferromagnetic material shown considerable increase in susceptibility and exhibit well known is the hysteresis. Is the second one. The BH curve already learned in 12th standard, or the BH curve. The BH curve, the hysteresis loop exhibited by ferromagnetic material. This is the Curie temperature, or this is the critical temperature is greater than actual temperature. The OC, suppose this is the diagram, the OC, suppose this point is O and this is the point C. This O and C, this process is the corrosive force. Sorry, this is the residual force, not this is the corrosive force, this is the residual. It is also called as residual force, OC, and corrosive force is OD. OD is the corrosive force. This space and this point is called as residual flux density, SC, corrosive force. Okay, this is the when ferromagnetic material is subjected. Suppose the relation between magnetic field strength H and magnetic flux density is B will follow a curve up to point where further increase in the magnetic field strength will result in no further change in flux density. Suppose this is when ferromagnetic material is subjected to increasing or decreasing magnetic field, the changes in flux density is B when plotted against magnetizing force is H. H is the magnetizing force and B is the flux density. H in hysteresis loop, and this curve is called as magnetizing curve or magnetization curve. The hysteresis loop starts from point O. This is point O when the field strength is magnetizing force is H is increase. Okay, field strength is increase. The flux density B also increases. Magnetizing force increases, flux density also increases from O to point A. O to this point A, this is saturation. Okay, this is the point, the saturation of magnetic material takes place. So point is also called as saturation point. This is called as the saturation point. Now if we decrease the magnetic field strength, suppose saturation, here saturation decrease the magnetic field strength at point A. Okay, this point A, the same path of OA, the same path is OA is not retracted but curve takes now path AC. Okay, the path A, B or C, the AC path. Okay, at point C, suppose this point C, it is found that even if the external field is H, external field is X, H is 0, still magnetic field density is Br is present in the material. This Br is called as remnant flux density. This Br called as the remnant flux density. This point remnant flux density. Okay, in present in the material, this Br is called as remnant flux density और रेसिडुअल फ्लक्स डेंसिटी. इसको क्या बोलते हैं अभी, रेसिडुअल फ्लक्स डेंसिटी बोल सकते हैं और रिमेनेंट फ्लक्स डेंसिटी भी बोल सकते हैं. Then residual magnetism means what is the residual magnetism? What is the actual residual magnetism? Is the amount of magnetization left behind after removing the external magnetic field from circuit. That is the value of flux density retained by the magnetic materials is called as residual magnetism, and the power of retaining this magnetism is called as retentivity of the material. What is the residual magnetism can reduce by the following methods. This reduced by 40 to 55%. I think 40 to 55% by the use of hot rolled steel material. This is a reduce, okay, by providing the higher exhibiting current, or the what is the explanation of coercive force. This is the coercive force is a coercivity or coercive force. The make br, br means what is br is the remnant flux density. Okay, br is the remnant flux density, or is the coercivity or retentivity. This is the retentivity, or it is a coercivity, it is a decreases. Okay, make br is 0. Okay, suppose this is the 0, magnetic field is applied reverse direction. This is the reverse direction equal to OD. This is the point O. Okay, and same point is the D. Okay, OD. So at point D, the remnant flux, point D is the remnant flux density becomes 0. This becomes 0. The field which is applied reverse direction makes remnant flux density is also 0. इज कॉल्ड एज कोरेसिव फोर्स. उसको क्या बोलते हैं आप? कोरेसिव फोर्स भी बोल सकते हैं. आफ्टर पॉइंट डी, after the point D, H is increase. The magnetizing force is again increase. Magnetizing force again increase in reverse direction, the negative side. Okay, the reverse direction. Then B also increases negatively. B also increases the negatively. Then the point of E is obtained. This point of E is the obtained, or point of D is obtained. Sorry, not point E. This point D is obtained. B is maximum. Suppose density, flux density is a maximum but opposite direction. Continuing in this way, the curve EG, EFGA. Okay, this is the EF GA, EF. This is a GA or EFA. Okay, EFA is the obtained and cycle is completed. This cycle is completed. The loop of a c d a b c d a b c d, correct? No, this is the a b c d e f a. Okay, this is a uh, called as hysteresis loop. A B C D E F A. This is a hysteresis loop. Okay, the area under hysteresis loop represent energy loss during that cycle called as hysteresis loss. The hysteresis loss, OC, is the remnant flux density. OC is the remnant flux density, and then Br is the remnant flux density. This remnant flux density Br is present even the applied external magnetizing force H is 0. Okay, this H is 0. Under this condition, the material is said to be spontaneously magnetized. Okay, then it is the start from the no magnetizing specium M is equal to 0. The magnetization is already explained. This is the hysteresis curve. The thank you, students.